Go to the final two questions on review sheet number 2. Number 13, at 11 o'clock, the sun casts a shadow on the ground which is 12 feet in length from a building. The angle of elevation from the end of the shadow to the top of the building is 52 degrees. Using this information, draw a diagram and use trigonometry to find the height of the building. Round your final answers to 1 decimal place. Now I read that class just like you read it and I get lost in the details. Let's take a look at what data they gave us. The sun casts a shadow on the ground. Let's go ahead and show that. So the sun is going to cast a shadow on the ground. So there is kind of what it looks like to have a ray of sun coming from the sun hit the corner of the building. Here is our shadow right here. And our shadow is 12 feet. Oop, let's change that to a different color. Can we do that still? No. So the shadow is going to be 12 feet. And then it says the angle of elevation from the end of the shadow, which is right here, the end of the shadow, to the top of the building is 52 degrees. That is this angle right here, 52 degrees. So now you can see, class, we just have a right triangle. This is a right angle right here. We've got a right triangle. And we're going to use trigonometry to find the height of the building, and that's right here. So the height of the building, let's just label that as x. So there is our variable x. And let's go ahead and write out SOHCAHTOA and see if we can solve this. So let's write SOHCAHTOA. And I'll write out everything for those of you seeing all the steps. So our reference angle is going to be 52 degrees. Again, we don't have to label A, B, C on this. And reference angle is 52 degrees. I know, whoops, I should be labeling my parts. This is the hypotenuse from here to here. The x, the 12 feet, is, here's our reference angle, 52, and that means 12 feet is the adjacent side, and the x is the opposite side. I'm not sure how I'm going to write that in here. I'll just write on top of the house, opposite. Okay, so we know the adjacent side, or the shadow. We want to know the height of the building, which is the opposite side. So opposite, adjacent, opposite, adjacent. And that means we're going to use tangent. So our equation is going to be tangent of 52 degrees is equal to opposite, which is our unknown side, over adjacent, which is 12. We have a variable again in the numerator. That means we multiply both sides by the denominator. That will cancel the 12 on the right and move it over to the left. 12 times tangent of 52 degrees equals x. And that means x is approximately, let's take a look, 12 times tangent of 52 degrees equals, we've got 15.35. The 5 is going to round the 3 up, so to 1 decimal place, that's 15.4. 15.4, and that's going to be in feet. So our sentence answer is the height of the house, and I'll just have you write it. The height of the house is 15.4 feet. You should be writing that on your own. Actually, you know what, class? I know that some of you, no, let's just put on here sentence. To remind you, if you want full credit for this review, you got to write that as a sentence. All right. 6 hours later, in number 14, 6 hours later at 5 p.m., the angle of elevation from the end of the shadow to the top of the building is now 16 degrees. Draw a diagram and find the length of the shadow. The length of the shadow. So look at question 13. We're looking for find the height of the building. Now we know the height of the building. The height of the building is 15.4 feet. The building did not grow when the sun moved, so we know that value. Now we got to find the length of the shadow. So let's go ahead and draw our sunbeam again. The sun is now lower in the sky. It's going to make our shadow longer. There is our sunbeam. And we know that the angle of elevation at the end of the shadow is now 16 degrees. And we know the height of our building is 15.4 feet. So I'm going to label this 15.4 feet. And the question is, what is the length of the shadow? That makes the distance from the end of the shadow to the building on the ground. That makes it our unknown side. Let's go ahead and label our triangle. We know this is hypotenuse. This side over here, the building height is still opposite, OPP, and the x value is now adjacent to our known reference angle. All right, let's write SOHCAHTOA. SOHCAHTOA. And our reference angle is now going to be 16 degrees. The side we know is now changed. The side we know is now opposite, and the side we want to know is our adjacent side. So we're still going to be using, here's opposite, adjacent, opposite, adjacent. We're still going to be using tangent, but now you can see the roles have reversed. It used to be that we knew the adjacent side and wanted to know opposite. Now we know opposite and want to know adjacent, but still going to be tangent. So tangent is our trig function. Tangent of our reference angle is equal to opposite, which is now 15.4, that's the height of our building, over adjacent, which is unknown. Now in this case, class, now we have a little different scenario. Our variable is in the numerator of our fraction. So now we can use Algebra 1 shortcut to know that the x, I'm going to draw this out for you, the x gets to move to where tangent 16 is, and the tangent 16 moves where the x is. So we're going to rewrite this equation as x is equal to 15.4 over tangent of 16. Notice the numerator 15.4 doesn't go anywhere. The x and tangent 16 flip places. We can actually put that in our calculator now. We've got 15.4 divided by tangent of 16 degrees, and that equals 53.7. And I'm wondering here, 15.4, let me check it out one more time to make sure I have that right. I've got 16 degrees, I've got 15.4. Let's do it one more time to check that answer. 15.4 divided by tangent of 16 equals, and the answer is 53.7. 53.7. So that is the length of our shadow, 53.7 feet. And I would expect again that you write your sentence right here. Your sentence answer goes right there. Something like, the length of the shadow is 53.7 feet would be an acceptable sentence.